Let's move on to chapter 4. And we almost covered first 3 sections. As we were discussing connected bodies, okay, covered. I think we were here, exam style questions. Question number 6. Two particles A and B of masses 10 kg and 5 kg respectively are connected by light inextensible string. Particle B hangs directly below particle A. Okay. A and B. Particle A, particle B. A is of 10 kgs, B is of 5 kg. B hangs directly below A. A force of 180 Newton is applied to A vertically upwards, causing the particles to accelerate. The force of 180 Newtons is going upwards. Find the magnitude of acceleration. So if we see from acceleration, we use F equals ma, where F is net force. Net force is forward force, that is upwards, minus resistive force, which would be weight of these two. So total mass is 15 m into g is equals to mass into acceleration. So there we simplify. It is 180 minus 15 into 9.8, that is 33. So 33 by 15 is the acceleration. It makes 2.2 meter per second square. So find the tension in this string. Consider this isolated body A, and we are using F equals ma. So net force, upward force, when we use this A as isolated body, it is 180 upwards, minus the tension in the string, which is downwards, and minus the weight of the object, which is mg, 10 into 9.8 is equals to 10 into acceleration is known, which is 2.2. So we simplify. 10 into 2.2 is 22. I'm bringing all the numbers to left hand side. So 180 minus 98 minus 22 and t on the other side. So 180 minus 98 minus 22, and it is 60 newtons. So let's try same thing with particle B. If we isolate this particle B, now tension is the only thing which is moving upwards. So it should be F equals ma. Upwards is T and downwards is the weight. And weight is 5 into 9.8. And mass is 5, acceleration is 2.2. So 5 into 2.2 plus 5 into 9.8 is again 60. So no matter how we do it, you always get the same answer. 7 says two particles A and B of masses 6 kg and m kg. Let's use this space. Okay, we have two particles A and B, 6 kg and m kg. Respectively are connected by light inextensible string. Particle B hangs directly below A. So we have particle A, B hangs below it. A is 6 kgs, B is m kgs, that is unknown. A force of 118 newtons is applied to A vertically upwards, This is moving upwards 180 Newton, causing the particles to accelerate with 2 meters per second square. Find the mass of particle B. So we have the acceleration, and if we use our equation F equals ma, where F is net force is upward force, which is 118, minus the downward force, which is weight of A and weight of B. So weight of A should be 6 into 9.8, and weight of B is mass into 9.8 is equals to total mass 6 plus m, and acceleration is given, which is 2. So the only unknown in this equation is mass. So 118 minus 6 into 9.8 is 58.8 minus 9.8 m, and on the other side 6 2 times is 12 plus 2m. Now we rearrange 118 minus 58.8 minus 12 is equals to 9.8 m plus 2m. So 118 minus 58.8 minus 12 is 47.2, and on the other side 11.8 m. So mass is 47.2 by 11.8. which is 4 kgs. Clear? B part says find the tension in the string. So again, we can consider any one body to solve for it. And suppose we consider this body A as isolated. So upward force at particle A is F equals ma, upward force is 118, and downward force in this case is the tension and weight of A, which is m into g. On the other side, mass is 6 and acceleration is already given, which is 2. So 118 minus 6 into 9.8 minus 6 2 times is 12, and t goes on the other side, and we simplify. 118 minus 6 into 9.8 minus 12, and tension is 47.2 newtons. Let's try the same with particle B if we get the same answer. So if we are solving for particle B, again F equals ma, upward force is tension, downward force is the weight, m into g is equals to m into acceleration. So tension is equals to 4 into 2 plus 4 into 9.8. So 4 2 times is 8 plus 4 into 9.8 is 47.2. So we get same tension. Question number 8. A train engine of mass 6400 kgs is pulling a carriage of mass 1600 kg along a straight horizontal railway track. The engine is connected to carriage by a shunt which is parallel to the direction of motion of the coupling. The shunt is modeled as a light inextensible rod, so no mass, nothing. The engine provides a constant driving force of 12,000. So meanwhile we can just draw. Let me say this is the engine and this is the carriage. They are connected. Engine's mass is 6400 kg. Carriage is 1600 kgs. They are connected by a shunt, and driving force of engine is 12,000 newtons. The resistance to motion of the engine and the carriage are modeled as constant force of magnitude R and 2000. So R is the resistive force on the engine and 2000 newtons is the resistive force on carriage. Given that the acceleration of the engine is 0.5, acceleration equals 0.5 meters per second square, and we have to find R, and then we have to show the tension. So let me note this down here. A is R, and B part we have to show that tension is equal to 2800 newtons. Okay, so let's do it. First part is R. So we apply F equals MA again. F equals MA, net force. So forward force in this case is only 12,000. There are two resistive forces. One is 2000. The other is R. On the other side, we use MA. So total mass is 6400 plus 1600, and acceleration which is given in question, that is 0.5. So we simplify. 12,000, 2000 will left with 10,000 minus R. On the other side, 6400 plus 1600 is 8000. So 8000 into 0.4 is 4000. Rearrange. 10,000 minus 4000 equals R. So resistive force is 6000 newtons. And then we have to show that the tension in the strut is 2800. Now we consider this body as isolated, and we apply F equals MA. Forward force is 12,000. Forward force is 12,000 minus the resistive forces. There are two resistive forces. One is R, which is 6000. The other is the tension in the strut, which is backwards. Tension is always away from the body. And mass is 6400. Acceleration is 0.5. So we solve for T. So 12,000 minus 6000. 6400 into 0.5 is 32. Minus 3200 is equals to T. So 12,000 minus 6000 minus 3200, and T is equals to 2800 newtons shown. Question is complete, but still I'm doing it for the sake of concept with this carriage. If we consider this body, it will be F equals MA. Now forward force in this case is this tension. Tension is always away from the body. So tension is towards right hand side, and towards left hand side is 2000. On the other side, M into A. So tension is equal to, we take this 2000 on the other side, sign changes to positive. 16 into 0.5 is 800, and 2000 plus 800 is 2800 newtons shown. Clear? Box P of mass 2 kg rests on a rough horizontal table attached to one end of the light inextensible string. The string passes over a smooth fixed pulley at the edge of the table. The other end of the string is attached to Q 1.5 kgs, which hangs freely below the pulley. Magnitude of frictional force between P and the table is K newtons. The system is released from rest. The string taut after release. Q descends a distance of 0.8 and 0.75 seconds. Model P and Q as particles. Calculate the acceleration of Q. So S equals UT plus half AT square, because this information is given. Displacement covered is 0.8. Initial velocity 0, it was at rest, plus half acceleration unknown, and time is 0.75 seconds whole squared. So we rearrange and solve for A, that is 0.8 into 2 divided by 0.75 squared, and the answer is 2.844. So acceleration is 2.84 meters per second square. 2.84 meters per second square. Second part says show that the tension in the string is 10.4. So if we are talking about this, let me change this color. When it is moving down, that means weight is more than the tension equals MA. So weight is 1.5 times 9.8, and tension is upwards, that is unknown. Mass is 1.5, acceleration is 2.84. So we again rearrange 1.5 into 9.8, and when we bring MA on this side is minus 1.5 times 2.84, we get 10.44, and T on the other side. So it is approximately equal to 10.4 to 3 significant figures, exactly equal to 10.4 newtons. Find the value of K. Now when we know the tension, this is one string and they're connected, so tension is equals to 10.4 newtons. So equation of P, right equals left. If it is moving towards right, tension is more, then the friction equals MA, and tension is 10.4 minus K, mass is 2.5, and they are connected, so connected bodies have the same acceleration, which is 2.84. So 10.4 minus 2.5 into 2.84 is 7.1 equals K. So magnitude of K is 7.4 minus 7.1, that is 3.3 newtons.